evening, guys. Welcome to the 2026 spotter training. Dr. Biggs here from National Weather Service out in Norman. Also, we do have cookies, muffins, tea, coffee, water. The muffins were donated by Perkins Restaurant. The tea is HTO and Tonka. They all donated, all of it. The water was by State Farm. So you guys eat and drink all you guys want. If you guys have to leave. No hard feelings. You won't have any hard feelings. He said he's going to try to keep it under 4 hours tonight, so we'll all be home by 10 o'clock tonight, okay? All right, I'll turn it on over to Dr. Vic. Thank you guys for coming tonight.
All right, thank you, Brian. Yeah, I'm meteorologist Blackwell from the National Weather Service in Norman. Welcome to our spotter training class. How many of you attended a spotter training class before? Awesome, so we have a lot of veterans here in terms of spotter training. So hopefully you'll see some new things. It's been a while since we've actually had it in Blackwell. We've had it in Ponca City, Enid, and other areas, but it's been quite a while since we've had it in Blackwell, so I'm glad to be here. You guys have a really nice facility and appreciate the food and everything here. So we'll get started here. So this is our county warning area. This is what the Norman Forecast Office actually covers. We cover 56 counties across Oklahoma, and we actually go into western North Texas. So we actually have 8 counties in western North Texas. So we have a fairly large area. But I did see some of you guys from Osage County. Raise your hand from Osage County. Yep. Osage County, that is actually technically covered by the Tulsa County warning area, but Tulsa is, part of the national, we're all one National Weather Service. We are always communicating with the Tulsa Forecast Office, and Tulsa is actually our primary backup office. So, if we go down, Tulsa is the first one to take over our operations and vice versa. So we are always in communication with our surrounding offices. Oklahoma actually has 4 offices that cover the state. The Panhandle is actually covered by the Amarillo office. Then we cover, western 2/3. Tulsa covers the eastern half of the state, or eastern third of the state. And then one county, McCurtain County in southeast Oklahoma, is actually covered by the Shreveport office. So 4 offices. So the mission of the National Weather Service is to provide climate, water, weather forecasts, and warnings for the protection of life and property and the enhancement of the national economy. A key phrase in there, of course, is the protection of life and property. And all of you play a role in that as storm spotters, because storm spotting is really, really important, because we don't know what's happening in the local communities, especially in the more rural areas. If you've watched broadcast media, they tend to focus on things, near Tulsa or Oklahoma City, especially if there's a tornado in Oklahoma City or near Tulsa. So, especially in the rural areas, we really depend on all of you to give us reports. So this is what our operations floor looks like. How many of you have been down to the Weather Center? We have a National Weather Festival that we have every year. I think it's November 7th this year, so encourage you to come visit. It's an open house for the entire building, especially if you have any kids that are really into weather. The National Weather Festival is a great opportunity, but this is how we operate during severe weather operations, and we usually have 10 to 12 people during severe weather operations. So this is just kind of a sneak peek of what we do on a day-to-day basis. And you can see, for example, there's Phil here. He looks like he's doing some flash flood products. So, during severe weather operations, we may have 2 or 3 people doing severe thunderstorm warnings, tornado warnings. We may also have someone doing just hydro, like flash flood warnings. We also have people doing aviation. We do aviation actually for the Ponca City Airport. That's one of our 9 aviation sites that we do forecasts for. So, here's some goals of spotter training. Number 1 goal when storm spotting is stay safe at all times. No report, no picture, no video is worth your life. So that's always the number 1 goal. Second goal is to be the eyes for the National Weather Service and local emergency management. And you want to communicate that information, with your local EM and with the National Weather Service. You want to get that report out because, again, we may not know about it. So you want to safely observe, identify, and report. It's also important if the report is timely. Of course, if you give us a report of damage the next day, that's still useful information, but in terms of a tornado or hail that's ongoing, the faster you can give us that report, the better. You want to be clear, calm, and concise. In other words, don't be too much of a panic while on the phone, hopefully. And objective. You only want to report what you see, right? Don't make assumptions. You may not be able to tell if it's a tornado. Say that. I can't tell if it's a tornado. You want to be objective. So what we see on our screen is usually radar data or satellite data, and this is what you see out in the field. And the big part of it is, radar is scanning up above the ground. So this is what the radar is telling us, information that's happening above the ground. So we can use that to make a really good forecast of what's happening at the ground, but we don't truly know a lot of the time what's happening on the ground just based on radar. Sometimes we can if we see, for example, a tornado debris signature on radar, but a lot of times we can't tell exactly what's happening on the ground. So this is why we need storm spotters. You guys fill in this void, data void, beneath the radar beam, essentially. And you guys are all part of the integrated warning team as storm spotters. So we have emergency managers. And emergency managers in this context is broad. It's not just the local EM, but it's, the local fire chief that might be sounding the sirens, etc. There's emergency management. It's very broad. A lot of times people wear multiple hats in emergency management. And then the media, the National Weather Service, and then you all as storm spotters are the missing puzzle piece that gives the reports. So let's look back at 2025. This is all the tornadoes we had reported across the United States. We had about just over 1,500 in an average year, about 1,400. So relatively, about average, or maybe just slightly above average. Out there, a lot of tornadoes actually across the Midwest, Missouri, Illinois, Indiana, Northeast Arkansas had some. And we had 67 deaths across the country. And you'll notice where most of them were in mobile homes or in their home or building. But we had some that were in vehicles and a few outside as well. In 2025, and I'll talk about 2026 in a second, in 2025 we actually only had one death in Oklahoma. That was on April 19th in Hughes County, where it was an 84-year-old man. It's a sad story because they did have a tornado shelter, but the man didn't want to go into the shelter. So, unfortunately. And there's a picture of the storm shelter that they had. So we had 106 tornadoes. Again, on an average year, we had 59. The good news is most tornadoes, again, are weak tornadoes. I use that term loosely. If it hits your house, it's not a weak tornado, right? Any tornado is a bad tornado, whether it's an EF0 or an EF2. But relatively, EF0s and EF1s are considered weak tornadoes. 2s and 3s, usually considered strong, and then 4s and 5s are unknown. The unknown basically means we just didn't have enough damage indicators to rate the tornado. That's what the EF unknown is. So, again, most tornadoes in Oklahoma happen in April, May, and June, but tornado season, I always tell people in Oklahoma, is 365 days of the year, 366 if it's a leap year, because you can basically have a tornado any time of the year in Oklahoma. And we've seen it. I mean, last year we had 2 in November. We've had tornadoes in December. So it doesn't matter what time of year it is here in Oklahoma, because as you've seen, we've been fairly warm this winter. So when you have a warm winter, you are more likely to potentially have, whether it's fire weather or severe weather a lot of times. So in 2025, the strongest tornadoes, we had one up in Ellis County near Arnett, one in Pittsburgh County, those were 2 EF3s, and then we had 3 EF2s, Love, Marshall, Ellis, and then one in Ellis and Roger Mills County. 2026 is already starting to be a very busy year. We've already had 25 tornadoes. We actually set a record for the month of March with 20 tornadoes. And the unfortunate part about this is we've actually had already 4 fatalities in the state of Oklahoma, which is, unfortunate and very sad. One of them, many of you have probably heard the story, was in Major County where a mother and daughter were in their vehicle trying to head home, and 2 fatalities in the vehicle. And then a couple in their house in Okmulgee County also got directly hit by an EF3 tornado, and that was on the Beggs Liberty area. So unfortunately, we're starting off kind of as a busy year. All right, let's talk about spotter safety. We all, like I've been saying, safety is always number one. Respect the storms. They can hurt or kill you. They are storms that are deadly. So you always want to know your location, the storm's location, storm motion. And we don't encourage people to storm spot in their vehicle, but if you are storm spotting in your vehicle, you always want to have multiple escape routes as well. And how many of you have a radar app on your phone? A lot of people do now, which is great, right? But as soon as you get that radar data on your phone, it's already outdated, right? It's already old data. So you definitely can use radar to be safe and informed. It's really great to see what's happening and trends and situational awareness and to avoid a storm sneaking up on you. It's a great way to see kind of storm motion, storm type. All our warnings usually show up on most radar apps, so you can immediately see the warnings that we issue at the National Weather Service. You can kind of see the danger areas, the polygons. You can kind of see what you're looking at. Is it a supercell, a squall line? Radar is a great tool. Other storms in the area. But again, radar has this limitation. It doesn't pinpoint exact locations, can't detect every tornado, hailstorm, or wind gust, and the algorithms aren't always accurate. And like I said, it's always technically outdated data. One of the biggest hazards for storms, this is for any thunderstorm, is actually lightning. Actually, as a meteorologist, that's the hazard that scares me the most, because I can usually tell, all right, there's a tornado there, I can tell where the hail core is, I can tell where those things are visually. I cannot tell you where the next lightning strike is going to be in that storm. So as a meteorologist, lightning is actually what scares me the most, because I can't tell you where that lightning strike is going to hit. And I've seen lightning strikes more than 10 miles away. I've seen cases where it's like 30 miles ahead of the storm, because the angle from that storm sheared way downstream. You get lightning strikes 30, 40 miles ahead of before you get precipitation. So to me, lightning is actually the most dangerous. In 2025, we had 2 fatalities from lightning, and these people, one was walking and one was at Lake Texoma. And most of these activities most lightning deaths are when people are doing, outdoor activities, fishing, hunting, golfing, at the beach. So that's a hazard no matter what the thunderstorm is. And I don't have the stats here, but some of the past stats have shown tends to be men more than women that get struck, which maybe that's why men have lower life expectancies, I don't know. But it's probably because men tend to do more of these outdoor activities. But bottom line is lightning is dangerous no matter what the storm. So you want to shelter in a strong grounded building, or if you have to be in a vehicle, that's better than being under a tree. Keep your vehicle windows closed and avoid contact with anything that may conduct electricity from the outside. So the best shelter obviously is a sturdy building that out there. Don't touch anything plugged into outlets or plumbing, so don't take a shower while you're, have a lightning storm out there, because if the lightning strikes your house, it may go through the plumbing. You want to avoid that. Another hazard is obviously hail. In Oklahoma, we get really, really large hail. And it can be pretty bad hail. And hail can come down at around 100 miles an hour in the largest hailstones. So you don't want that hitting your head or your vehicle. So obviously hail safety, stay inside, measure it after it stops. So again, like I said, no picture, video is worth your life. You don't want to be outside and this is happening. I've seen hailstones actually go through people's roof when they start getting this size. Another big cause, which is hard to believe since we're in an ongoing drought here in Oklahoma, but flooding, is a big thing too. In our part of the world, a lot of them are in vehicles, because we don't tend to get as much rushing water situations where people are getting water rushing into their houses in Oklahoma. it can happen, but it's rare. It's more tends to be in people's vehicles. But in 2025, we had 7 in Oklahoma, and 173 in Texas, but that was from that camp, if you remember from last year, summer, where the camps, the Mystic Camp, we had the fatalities with the kids there, so they had 173. Large portion of that was due to that big event down in Texas. And then in Oklahoma, again, all of the ones in 2025 were in vehicles. So you don't want to do what this vehicle did. This will really annoy law enforcement and emergency managers that are here too, because now they have to potentially rescue you, right? So if those barricades are there, don't go around the barricades, because you don't, but it shouldn't do things like that. Oops. Not a very smart move, right? So, I bet your insurance company won't be very happy either. So if you see rushing water like that, obviously turn around, don't drown. If there's barricades, those barricades are there for a reason. Don't go around the barricades. So flooding is another big thing. Obviously tornadoes, again, like I said, most of them happen March, April, May, June, but again, they can happen any time of the year here in Oklahoma. And we'll go into obviously more details on how to spot those storms. I'm just talking about hazards in general right now. Most tornadoes here, about 2/3, happen in the late afternoon to early evening hours, so 3 p.m. to 9 p.m., about 66% occur during that time. But again, tornadoes can happen any time of the year and any time of the day. Oklahoma tornadoes typically move from the southwest or west to the northeast, but there have been situations where they can do weird loops and other things, and I'll show an example of that later. Average speed of tornadoes is about 30 miles an hour, and the good news is most tornadoes tend to be brief. Like I said, most tornadoes tend to be relatively weak, EF0 or EF1, but like I said, hits your house, it's not a weak tornado. And that's this chart here, about 68% are EF0 or EF1, but 110 mile an hour wind is still a really, really strong wind. All right, that's a strong wind there. I mean, if you have a mobile home that's not secured properly, an EF1 tornado could cause it to roll over, essentially. So even in a mobile home, an EF1 tornado, if it's not properly secured, can, cause significant damage. And then 3% of tornadoes are violent tornadoes. So those are the ones that, are the strongest, like the Moore tornado or the El Reno, tornado. Those are the tornadoes where we have winds of over, 200 miles an hour. Like the Moore tornado had over 200 miles an hour, for example, just from the DIs, essentially. We used damage indicators, and there was some significant damage with that. That was from 2013, if you remember that, May 20th, 2013 Moore tornado. Luckily, those are rare, but they do happen. This is an interesting map. This is the map of tornado tracks from 1950 to 2025 across this part of the state. And you can see, you may think you're safe right there in K County, but it's all an illusion, right? This is only, 75 years of data. So don't think just because you haven't had a tornado go through a certain location, you're safe, right? And contrary to popular belief, tornadoes can go over, water. They can go over county boundaries and lakes, etc. So just because you're nearby a lake, just because you're near a river, doesn't mean you're protected from a tornado. Yeah, a lot of tornadoes, move from southwest to northeast. So, Some of them do get kind of close to following, like up here, because of the way the river runs. But in some cases, they are, you know, kind of perpendicular too, because of the way the storms are moving. But you can see generally, like I said, most storms move from southwest to northeast. All right, tornado safety guidelines. So you want to get as far inside as you can, get as low as you can, put as many walls between you and the outside as possible, and cover up with pillows, sleeping bags, couches, couch cushions, and mattresses. So if you're got bike helmets, that's also great. If your kids have bike helmets, it's good to put those on them as well. So that's why I say wear a helmet. You don't want to be in a mobile home or vehicle. Like I said, even an EF1 tornado could, you know, cause significant damage to a mobile home. And then vehicles, of course, you don't want to be there as well. All right, let's talk about storm types and key features for spotters. So you've got the updraft right there. Everyone should be able to at least tell there's an updraft because there's no precipitation. Usually the updraft doesn't have precipitation below it because air is rising. Flip side, the downdraft is where you have the precipitation. So in a typical thunderstorm, you have an updraft and then the precipitation comes down as a downdraft. So those are the two key pieces of a thunderstorm. Now, a squall line, this is like a line of storms, or sometimes people call it a quasi-linear convective system, or QLCS. That often forms along a cold front. And a lot of times you have very heavy rainfall on the leading edge and strong winds along lines of storms. So this is a classic example of a line of thunderstorms. A line, usually immediately behind, you got the heaviest precipitation. The main threat with lines of thunderstorms is usually damaging wind gusts. And the wind gusts can be as strong as a weak tornado. So you could see winds of 80, 90, 100 miles an hour in a line of thunderstorms. So just because it's not a tornado doesn't mean the storm is dangerous. Occasionally, we do see embedded tornadoes. We sometimes call those QLCS tornadoes, embedded in the line. These usually are relatively quick developing, but they can still be very intense. You know, we've had EF1, EF2, QLCS tornadoes, and sometimes you can even have supercells ahead of the line or even embedded within the line, and we'll talk about supercells in a little bit. So the squall line, the big thing about a squall line is it has this kind of look right here, kind of where horizontal clouds kind of looks like it's almost rolled up in the horizontal. It might be hard to see it, but you kind of see this kind of roll cloud right there. So you kind of have low turbulent clouds, sometimes lots of motion. Again, you get damaging wind gusts, possibly near this kind of shelf cloud right here, gust front. So you see this leading edge right there. A lot of times this cloud goes across the whole horizon. And that's the difference between that and a supercell. Supercell wall cloud is usually a very confined, small area, while shelf cloud, some people call them roll clouds, but shelf cloud has this look right here where it's just more, almost looks like I call it a shelf cloud because you can almost see it's like shaped like a shelf where you can put books or something in there. But that's the main thing with those is damaging wind gusts. But again, like I said, you can actually have vortices embedded within the line. These are called QLCS mesovortices, and these can be as strong as mesocyclones associated with supercells. They are different than supercells though. So here's what a classic supercell looks like on radar, and this is what a QLCS looks like. You see all these little circulations embedded in there. So not all mesovortices within QLCs produce tornadoes, but the stronger, long-lived, and deeper mesovortices are more likely to produce tornadoes. And like I said, they tend to maybe be more transient, but they can still be fairly intense. Visually, they will look different. So you will not expect it to look like this. A lot of times, the tornadoes are going to be rain wrapped in this situation. So an example case here, this is from 2023. We had a line of thunderstorms that went through central Oklahoma, and we had really strong winds. This is all these bright blues, but we also have these little embedded circulations that kind of move through. There's one right there that produced a tornado in Norman there. So these are, again, what we call QLCS tornadoes, and I'll show you a closer look here. They look like little supercells embedded sometimes, where they have little hooks in there, but this produced a tornado embedded in the line. So lines of thunderstorms can produce tornadoes, and especially in this part of the state, a lot of times the QLCS tornadoes tend to happen across the eastern half of Oklahoma, near I-35 to the east. So you guys are right on the edge where we tend to see more QLCS tornadoes. Because what happens, a lot of times you get supercells developing in western Oklahoma, and then they grow into a line of thunderstorms as they move eastward toward the I-35 corridor, and that's how you get the QLCS tornadoes a lot of times here in Oklahoma. So I've talked about supercells. If you've been in Oklahoma any amount of time, you've hopefully heard of a supercell. So supercells are a thunderstorm with a deep, persistent, rotating updraft. That's the key word, rotating updraft. That is called a mesocyclone. So it's a rotating updraft, and these can produce all forms of severe weather. And usually these are the ones that produce the largest hail. So the ones where we talk about 4, 5, 6-inch hail. They come from supercells. And usually the most violent, significant tornadoes tend to have associated with supercells. So the EF4s and EF5 tornadoes are usually associated with QLCSs. Or sorry, with supercells, not QLCSs. QLCSs tend to be more the EF0, 1, 2s, and sometimes we've had 3s and QLCSs, but they're rare. But the EF4s and 5s tend to happen with supercells. And they can be long-lasting storms given the right conditions. I've seen supercells that start near the Oklahoma-Texas border and make their way all the way to Arkansas. So they can track a long time and produce tornadoes through their track. So, like I said, every storm, is going to have an updraft. So you have inflow, which is warm, moist air that goes up, and it comes back down as a downdraft. And that downdraft produces what we call outflow, which is cool air. The zone between this downdraft and updraft is actually what we call the action area. So it's between the updraft and the downdraft region. And that's where we often see the tornadoes in a supercell. Here's another picture. There's a lot of pieces with the supercell. So again, you've got the updraft. And notice this updraft, the air is spiraling up because it's a mesocyclone, and then the precipitation comes back down, and you've got cool outflow. And really, there's actually 2 downdrafts in a supercell. I'll show you that in a little bit. There's the forward flank downdraft, where you get most of the heavy rain and hail, but then you also have, on the southwest side, the rear flank downdraft. And that's how you get that hook shape with the supercell. So again, you've got the updraft, you've got the downdraft, again, you've got another downdraft down there. And then this is the critically important feature. This is what makes a supercell, is the mesocyclone there. And then again, that action area is between that updraft and downdraft there. So this is what you probably are used to seeing on radar, right? When you see supercells, you probably have seen this on television a few times. Well, what the radar is measuring is actually the intensity of the precipitation. So all this reds and oranges, that's heavy rainfall and some hail in there. In this case, this is probably a debris ball right there. So the radar is actually detecting tornado debris in this situation. So let's look at a supercell from above. So this is what, if you're looking from up in space, again, you've got the updraft, and then you've got the downdraft. So what the radar, again, is measuring, it's measuring precipitation coming to the ground. So the radar is not actually measuring the updraft, it's measuring all the precipitation in the downdraft. So that's why you see that hook shape on the radar. So that's all the precipitation that's in the downdraft region. You've got the mesocyclone right on the tip of the hook. You've got warm, moist air inflow. That's the energy for the storms. So all that potential energy is feeding into the storm right there. And then you've got outflow coming from the precipitation. And you've got also outflow coming in from the RFD. So these are all the pieces of a supercell. And then this is what it looks like on radar. So on radar, this is what you see. You see all the precipitation, and you don't really see the inflow. Sometimes you see the gust front and outflow showing up on reflectivity as well. So some clues for supercells usually have a rain-free base. Maybe hard to see in here a little bit, but what you see is basically this base right here, and there's no precipitation beneath it because you have rising motion there. Typically call it an updraft base. And you often see a rounded updraft, which is what we call the mesocyclone. So there's one picture here. You can see how it's kind of rounded. Here's another one. This is actually at our office with a supercell overhead. And sometimes you see these little striations. They're like plates that kind of show up. So that kind of gives you indication that there is rotation there. So again, you've got the downdraft, updraft, rain-free base, and again, like I said, the action area is between the updraft and downdraft. So right in there, you've got the wall cloud. Between that interface between the rising motion and the downward motion, you've got the wall cloud. Sometimes the wall cloud will actually slope toward the precipitation. I'm going to show a lot of examples of this, but everyone here hopefully can understand this diagram because this is key to storm spotting. And part of the reason, storms are kind of tilted where the updraft and downdraft are not co-located is because we have upper level winds that gives shear, vertical wind shear, which is winds changing speed and direction with height, that allows the updraft and downdraft to be somewhat displaced. So a lot of times in the summertime the shear weakens, so thunderstorms don't last as long because the downdraft essentially chokes off the updraft because it loses that warm, buoyant air that's coming in. Here's another picture. There's the downdraft. There's the updraft right there. And again, that interface between the updraft and the downdraft, that is the action area. And in this case, we have a little wall cloud right there. Here's another picture. Again, updraft, rain-free base, downdraft, see updraft, downdraft, and that interface right there, that's the action area. All right, so let's talk more specific about wall clouds, funnel clouds, and tornadoes. A wall cloud is a lowered cloud beneath the updraft base. So again, it's different than a shelf cloud because it tends to be a lot smaller. Again, a shelf cloud tends to be a lot wider, a lot of times fills the whole horizon. Also, shelf clouds, like I said, are kind of more horizontal, kind of shaped, rolled, while the rotation here is more vertical. The orientation is vertical, where the axis of rotation is vertical instead of horizontal like in a shelf cloud. So again, it's in the updraft inflow region. Small clouds may or not be rotating. Right? And the big thing to report is organization and persistence. Wall cloud, again, tends to be between where the heaviest precipitation is and kind of that rain-free base, kind of that, again, that action area right there. And the radar part, if you're looking at it from above, it's located right on the tip of the hook, a lot of times for a supercell. So again, here's an example of a wall cloud. Here's another example. Again, strong inflow, and again, you know it's rising motion and inflow because there's very little or no precipitation there. So you're not getting any precipitation. You know, what's happening is you're having air rising. It's kind of the winds aloft are pushing it this direction, and then it's finally coming down. So the air is going like. And you have the strongest rising motion right there, where you've got the wall cloud, and then you've got the downdraft right there. So again, and then you've got this area right here between the downdraft and updraft where you've got this wall cloud. Again, the wall cloud may slope toward the rain, like I mentioned earlier. Sometimes it's also called a tail cloud. Here's another example of a wall cloud. Another example, again, you get all the precipitation right here, and then the rain-free base back here. I'm showing a lot of examples because every storm is going to be different, right? They're not all going to look exactly the same, but you look at more and more storms, hopefully you'll be able to tell where the important features are. Again, similar, here's the precipitation, rain-free base. You can even see the kind of the mesocyclone shape, where it's kind of surrounded right there. And it's important not only to report a wall cloud, but how it's changing. You know, tornado potential is increasing if the wall cloud is lower to the ground. You've got faster rotation, tightening circulation, and increasing inflow. So if you've got your back to the wall cloud and you feel warm air rushing into that wall cloud, that's important to report. You can say that you're feeling really strong, warm inflow coming in to that wall cloud. On the flip side, tornado potential is probably decreasing if you've got a higher cloud base. So if the wall cloud is lifting higher with time, the rotation is relatively weak. It's kind of broadening out, and the inflow is weak, or actually you feel outflow. If you feel cold outflow coming in from the storm, that probably indicates that the storm is what we call outflow dominant, and it's probably less likely to produce a tornado because that cold air is rushing out, and it may choke off the storm, essentially, prevent the warm air from feeding into the storm. So those are things to report. How is it changing? All right, we'll take a short break. Some of you need cleat credit. If you don't know what cleat credit is, then you probably don't need it. But if you're law enforcement and need cleat credit, we'll put this over here so you can sign that. We'll get back, let's see, give you about a 10-minute break. Let's see, what time is it now? So we'll come back in about 10 minutes at 7:20. I'll get you this cleat right in here. Grab some cookies and muffins too. We still have plenty over here. All right, we'll go ahead and get started with the second half of the training. Like I said, the cleat form is over there, and if you haven't also signed in, make sure to sign in as well, just so we can kind of have a count of how many people attended. So we'll go ahead and get started. Obviously, we're going to now talk about tornadoes and funnel clouds, spotter safety, spotting at night, and how to make a good report. So, we talked about wall clouds. Now we're going to talk about funnel clouds. Funnel clouds usually develop under or near the wall cloud. So, you just imagine you've got a wall cloud, and then you've got a funnel cloud, and then that can sometimes transition to a tornado. But sometimes, you know, in the most intense tornadoes, you may go from a wall cloud straight to a tornado because the whole wall cloud becomes the tornado. Key concept with funnel clouds, not in contact with the ground. If it's in contact with the ground, then it becomes a tornado. Rotation usually means a higher tornado potential when it's associated with a funnel cloud. Also, the closer it is to the ground. So here's another example of a funnel cloud. Big surprise, it's shaped like a funnel. It's connected to the cloud base. Again, a funnel shape, tapered cone, smoothish edges. You can see it's kind of smooth there. And like I said, usually rotating. But again, if there's no contact with the ground, then it's a funnel cloud, not a tornado. So here's another example of a funnel cloud. These are obviously very important to report because these can lead to a tornado. So a tornado is a violently rotating column of air that is in contact with the ground. So it's actually, you don't really have to say tornado on the ground because tornado by definition means it's on the ground. But if that gets people to take shelter, I'm fine with it. Because I know when people hear tornado on the ground, that instinctively tells them, oh, I need to take shelter. So technically, saying a tornado implies it's on the ground, but I understand, it's kind of become the norm to say tornado on the ground. Oops. And like I said, it's extending down from a thunderstorm. So this is a very, nice picture here that kind of shows the whole storm structure. The tornado is always a very small part. This kind of shows you the scope of a thunderstorm or supercell. You've got the updraft, you've got the mesocyclone, you've got a wall cloud, and then you've got the tornado, and then you've got the downdraft. So you can see in the whole scope of a thunderstorm, the tornado is usually a very small part, but it is a very impactful part of the storm. So this is just kind of showing how it looks like zoomed out, essentially. And again, you're looking at the tip of the hook there. So the key things you need to look at, if it's a tornado, do you have rotation? Is it connected to the cloud base? But the one that's a lot of times challenging is it in contact with the ground? Because a lot of times there may be something that's kind of blocking your view. In this case, you got some trees in here. A lot of times if you're looking, the horizon might be rising. You might not be able to tell if it's on the ground. So that can be a challenge. So you should never make an assumption. You should just report what you see. So you can say, I see a funnel, but I can't tell if it's in contact with the ground. I can't tell if it's a tornado. That's still important information. But again, you need to be objective. You need to tell us what you see and don't make assumptions. In this case, it's maybe hard to tell, but there might be some contact in the ground there. You actually see a little dust there. So it can be very subtle sometimes, but you have to have a clear view. And the tornado is the wind. It's not the cloud. Sometimes it'll be fully condensed. The cloud will be fully to the ground. But other times you may have a funnel, but you may have a debris beneath that funnel. So it's the wind, not the cloud. So in this example, you've got the tornado, and you've got the wind here by the kicked up dirt and debris, but it's not fully condensed, and sometimes it won't be fully condensed. All right, is this a tornado? How many say yes? How many say no? How many don't know? I see a lot of don't knows. That's why you're in the class, right? But in this case, a key thing you may want to look at is the fact that the horizon kind of comes up. So you really can't tell if it's on the ground. If you drive down this road a little bit, this is actually what you see. So, yeah, it may look like, oh, wow, that looks like a tornado. But you can't really tell because the horizon's kind of coming up. There's a hill up ahead. You can tell there's a hill. So just report what you see. In this case, you see a wall cloud, that's really close to the ground. But there's no tornado in this situation. But it could produce a tornado very quickly. So, your eyes can sometimes deceive you. There's optical illusions in nature, right? Is this a tornado? How many say yes? How many say no? How many also are not sure again? A lot of not sures, which, is fine. In this case, it is a little tricky, and it's a little tricky from a still image, too. If you have an animation, or if you're actually seeing it, you'll be able to tell a little bit more easily. But this is actually a rain shaft. This is actually rain in a very low precipitation storm. And one thing you can tell it's rain, you kind of see these streaks kind of there. It doesn't look as smooth. It doesn't look it looks kind of like little streaks of rain in there. So this is a rain shaft. So in this example, would you say this is a tornado? You should say no. What you should report is, I see a funnel. I can't tell it's a tornado because there's a tree or trees blocking my view. Now, if the trees weren't there, you would say, yes, this is a tornado. So this is what I mean by being objective. Because if you report a tornado when there isn't a tornado, then your friends downstream, hopefully like your friends in Osage County, may get a tornado warning that is not necessary, right? But again, it's always important to report what you see. Because the one thing the reports help, in real time, is it helps us with our, downstream warnings. So if you report a tornado warning in K County, then we could say, okay, this is a radar, this is a spotter confirmed tornado, and that increases the confidence to continue that tornado warning into Osage County. Now, we may still continue that tornado warning into Osage County just based on radar data, but having that storm report saying, hey, there is a tornado ongoing in K County, putting that in our tag, we put little tags in our warning saying this is a confirmed tornado, observed essentially, observed tornado from storm spotters, increases the confidence to keep that tornado warning going into Osage County. So things to think about when reporting a tornado: you want to be sure it's a tornado. Is it connected to the cloud base? Is it contact with the ground? Is it in the right part of the storm? So again, that action area between the updraft and downdraft that I was talking about earlier. Is it rotating? And can you see any debris? And debris is a very broad sense. It doesn't have to be, a house or a farm. Just dirt getting kicked up can be debris as well. Because a lot of, Oklahoma is rural, so luckily, a lot of times tornadoes, don't hit anything, but just, picking up a lot of dirt. And that still counts as, debris. And describing the tornado, report exactly what you see. A lot of times people report every tornado as a wedge or a large or a violent tornado. You want to, again, be objective and, only report what you see. Choose your words wisely, because your words will potentially impact how we message the warning and what type of warning we can do. We have different levels of tornado warning. We have a base tornado warning, but we also have something called the considerable tag. Considerable tag is usually used for the significant tornadoes. We tend to hit them for EF2s or stronger. And then we could even have what we call the tornado emergency. So the May 3rd, 1999 Moore tornado, that was the first time we used the term tornado emergency. That's usually for the most violent tornadoes. So, EF4s and 5s tend to get tornado emergencies. So we have different levels of tornado warnings based on what we think the intensity of the tornado is. And we use radar data. We can also use what we call the near storm environment. There's some environments that are more susceptible, ones that are really highly sheared, lots of instability. They are more likely to produce stronger tornadoes. And the storm mode too, like I mentioned, supercells tend to produce the strongest tornadoes, while yes, QLCS tornadoes can still be strong, like EF2, if you even had an EF3 QLCS, they're less likely to produce EF4 and 5, unlike supercells. And even supercells, like I mentioned earlier, it's a very small percentage that produce the most violent tornadoes. So even if you get hit by a supercell tornado, odds are it'll be more likely a weak tornado. Here's another example of a wall cloud, and you can see it's hard to tell, but there's a little bit of dust kicked up in there. and that indicates the presence of a tornado. And a lot of times, supercells are what we call cyclic, where they'll produce one tornado and that tornado will dissipate and then it'll produce another tornado. These are called cyclic supercells, where inflow is refocused a few miles east of the dissipating tornado, and then you'll see a new mesocyclone, a wall cloud form, usually to the east. And that'll become the dominant part of the storm. And the old tornado may actually have what we call deviant motion. And deviant tornado is any tornado perceived to move at a different speed or direction than its parent storm. So you could have a supercell moving to the northeast, but then you could actually have the tornado, during its dissipating stage, move to the northwest. And we've seen that happen before. So we've even seen tornadoes do loops before. That's what can make storm spotting dangerous, especially in a vehicle. So tornadoes don't always follow the storm motion. They can deviate to the right or to the left. The leftward deviation is usually when a tornado is about to dissipate. You may have heard of the term occlusion before. That's known as an occlusion. But the deviation does not tell you the tornado is becoming weaker or stronger. It could be weakening. It tends to usually weaken when it's turning to the left, but it could still be near its peak intensity. And the left deviation can be quite significant, chaotic, and you could again have loops. So that's what can make storm spotting in your vehicle very dangerous, because the supercell itself might be moving from the southwest to the northeast. So you may think it's okay to be here north of it, because the tornado is going to pass to my south. However, if the tornado begins to have deviant motion, it may go right on top of you and potentially hit you. So you never want to be, if you're in your vehicle, north in there. Especially also up in here, because you're going to be in heavy precipitation and hail, and you won't be able to even see the tornado. And if it turns to the north, you're in trouble. That's why you always want to be to the south or southeast of the tornado if you're trying to observe a tornado, because then you have a clear view to the north. You never want to look at a tornado from the north to the south. You want to look at it from the south to the north. For example, April 19th, 2023, these are the paths of the tornado this day. And you'll notice a lot of these had some loops. As a matter of fact, this one near Pink moved to the northwest. This one, started moving to the northeast, but then as it started to dissipate, it moved due north. So that's why we always tell people you always want a storm spot to the south or southeast, not to the north, because tornadoes can have that deviant motion. Now, there's a lot of other scary looking clouds out there. Something called gustnadoes. They look like tornadoes, but they're not connected to the cloud base. They're actually associated with the gust front. So a lot of times we have lines of thunderstorms. You may have a strong gust front, like it's basically a mini cold front, essentially. And the shear along that can create this kind of dust whirl in there. But these are still dangerous in terms of wind. You can still have 70 or 80 mile an hour winds here. So you could have a severe thunderstorm with these gustnadoes, but these are not tornadoes. And usually these are with lines of thunderstorms. You can have these little gustnadoes. You can have scud. These are kind of low-hanging clouds, but they don't really have much shape to them, and they kind of have this wispy look to them. This is a scud look. It's not as smooth and laminar looking like a funnel cloud, but it can look kind of scary. Here's another example of a scud cloud. Again, it just looks kind of messy, and a lot of times they kind of look not as smooth. And scud is still something to observe, especially if you have a wall cloud and you have rising, what's called rising scud underneath the wall cloud. That means strong upward motion in that wall cloud. So if you have rising little cloud particles rising into a wall cloud, that can indicate that wall cloud may be close to producing a tornado because of the rising scud. Again, here's the shelf cloud. Again, this is what we talked about earlier with the lines of thunderstorms. Difference, it kind of looks like a wall cloud, but again, The rotation is more in the horizontal instead of the vertical, and it usually covers the whole sky. But again, the big impact with this is you can have really strong winds. Again, lines of thunderstorms can produce 70 or 80 mile an hour winds. Here's another diagram of a shelf cloud. And again, you have the strong winds on the leading edge. Here's a video of a shelf cloud. You can see as it approaches, you see the turbulent motion on the leading edge. And again, you get the strong winds, and then you get the precipitation after that. We also have lattice clouds. These actually look very pretty, but again, a lot of thunderstorms produce lattice clouds. And just because you see lattice doesn't mean it's a dangerous storm. All right, spotting at night. We basically don't recommend it unless you really, really know what you're doing, because you can't really tell what's happening, especially here with the lights on. It's even lower contrast. So in the real world, it's hard to tell. There might be something there, but it's tough. A lot of times you have to depend on power flashes. When the tornado hits a transformer and causes a flash of power, or you have to depend on lightning. And it's hard. At nighttime, you can't really tell easily. Some storms don't produce a lot of lightning. Here you can kind of tell there's something right there, but it's tough and it's dangerous at nighttime. So if you see power flashes, you want to report it as a power flash. Don't assume it's a tornado, because like I said, even straight line damaging winds can cause a power flash, because those winds can be 70, 80 miles an hour. People have had power outages outside of tornadoes. So you can definitely get power flashes from straight line winds. We have to use that combined with radar and other data to help confirm a tornado. So how to report the information? How many have seen Twisters? Some of you have. So our WCM created this little meme. Basically, if you see it, report it. What to report? So our wish list. Tornadoes. You want to report, obviously, tornadoes that are signs that one will be developing. Funnel clouds, strongly rotating wall clouds. Hail, larger than 3/4 inch diameter, penny size or larger. Damaging winds, so damage caused by thunderstorm wind gusts. Measure wind gusts of more than 50 miles an hour. And then flash flooding. Key factor here is rapidly rising water in areas that do not typically flood. This is where we really depend on the local people, because I don't know every spot in your area where there normally floods. Like I know in Norman there's some spots that always floods, but I don't know. There's definitely places in Blackwell, in Ponca City that flood every time it rains. So we're really interested in areas that don't typically flood when you see rising water. So what is a severe thunderstorm? Hail 1 inch, larger, winds 58 miles per hour or stronger. Again, if you also get hail damage or wind damage, that's also important to report. You may not be able to see the hail, or you may not be able to measure the wind, but you'll see the damage after the fact. What not to report, you don't want to report heavy rain or rainfall rates. We can kind of tell from the radar if there's heavy rain occurring. Now, if you have actual rainfall amounts, that's good information. Like, say you have 5 inches of rain, that's really important. A lot of you probably are wishing for 5 inches of rain at this point. You don't need to report power outages, but any damage to power lines and poles, yes. Lightning, we used to have a person that would call our office and lived in Edmond, and she would call us every time she had lightning nearby, which, it's a report, but we can usually tell if there's lightning. And if everybody called us when there's lightning, our phones would be off the hook, getting calls all the time. So lightning is not needed to be reported. But if you have any damage from lightning or a fire from lightning, that's useful information. Scary looking clouds, what you see on the radar or TV. We had an event the major county event earlier this year, we were getting a lot of phone calls about people, what they were seeing on their radar apps. And, the thing is that, affects our operations because we are getting all those phone calls that we have to answer, where we might be having to do taking us away from another task, potentially. So, again, just give us what, is really beneficial to us on the right here. Obviously, what you see in terms of sirens or hear from sirens, we don't have to know about that either. So what, when, where, how, and key details. So what, what the hazard was, tornado, hail, wind, flood damage, when. Important part is, if it's happening now versus happened earlier is really important. Where did it happen, how, and key details. And one thing about the where, especially with the tornado, hopefully it's not the same location where you're giving the report. For reporting locations, try to give us, places that are easy to find on the map. Now, we've gotten some that are like, these county intersections, and we'll eventually find it, but it's easier to say something like, 2 miles west of Goldsby, instead of giving the county roads west of Goldsby. So if you can give us locations that are easy to find on a map, that's useful. Now, obviously, after the fact, if there's damage, the EM's reporting damage to us, we do want to know those county roads. And really what's actually the most beneficial if you have it is the latitude and longitude, because we can easily plug in the lat long. Like if you have a damage report and you have a picture and you have the lat long where you took that picture, that's actually the most beneficial. Because lat long we can easily, plug into a map for our software and figure out where it was. So latitude and longitude is really, really useful, especially after the fact. But nearest major intersection, avoid references only locals would know and understand. I mean, I'm sure there's a lot of terms here, locations here that I probably don't know in Blackwell. So, for tornadoes, funnel clouds, wall clouds, provide your location and the estimated location of the feature. Again, hopefully the tornado is not the same location as your location. That's probably, you probably need to do something else than giving us a report at that point. Again, estimate versus measure. If you have an object, golf ball, a line, put some sort of context if you're going to send us a picture or give us a report. We've gotten pictures before with just a hailstone in a hand, and they're like, well, is this an adult man's hand? Is it a young child's hand? That can make it challenging. So putting it next to an object like a quarter or a $50, I don't think people have those as much now, but if you have some sort of coin, golf ball, obviously the best thing is if you have a ruler, because that gives you an exact measurement. So if you have a ruler, that's great. If you really want to get extra credit, if you have a caliper, then you can, those give you a really good measurement. That's like bonus points there. But even having a golf ball or something next to it to add context is really useful. You want to report the largest size stone that you see, again, safely. And again, putting an object next to it helps. These are our typical, sizes. Again, hopefully you don't see these larger ones, but in Oklahoma we have there. But again, severe is quarter size and larger. Please don't use marble size because we don't know what size marble you're talking about. If you happen to get unlucky and you get giant hail at your house that's potentially a record, first of all, wait until the hail stops. Take pics before you move it. Put a ruler next to it for perspective. Avoid handling with bare hands. So this is how you can just document it. So we can send someone from the office there if you have a potential for a record hailstone. So we're talking about something that's like 6, 7 inches or larger. If you happen to get that, you want to try to measure the diameter where it's the widest and put the stone in a Ziploc bag and move it into a freezer ASAP. Contact the EM, obviously. If you don't know how to contact us, the EM will let us know that, hey, you may have had a record hailstone in your county. So this is, again, where we're talking about hailstones that are 6, 7, 8 inches. For example, we had this 6-inch hailstone in 2024 near Ada. So, yeah. Don't want that, but if you happen to get one, we would like to know about it, obviously. And, you know, the experts can do some math to get some measurements there. All right, estimated wind speed. Most people actually overestimate wind, usually. So this kind of gives you an idea of things that you can look at. So when you're starting to see damage to TV antennas, large branches break to trees, that's when you're starting to get to severe winds. If you're starting to get roofs peeled off, windows broken, trailer homes to overturn. So like I said, EF1 tornadoes can cause mobile homes to even overturn. That's, you know, you can see that in these winds around 100 or more. And if you're starting to see roofs blown from houses, trailer homes destroyed, you're talking about over 110, 113 mile an hour winds out there. So just remember that wind can cause damage as strong as a tornado. So people, a lot of times when they get hit by strong winds, you know, are very confident that it's a tornado. But you can have dangerous, destructive winds outside of a tornado. And then a tornado is also wind. Wind is wind. Whether it's a tornado or straight line winds, they can cause damage. So reporting wind damage, location, time, if known. If it's after the fact, you may not know the exact time. Description, images, video. Again, take pictures. A lot of cameras and smartphones usually now do include the GPS information, so that really helps if you can preserve the location, because GPS, you know, gives a really nice look. Like I said, don't assume it was a tornado. Flooding, you know, it's interesting what people report as flooding. Some people may actually report this as flooding. So if that's flooding, that's, you know, I mean, maybe to you it's flooding, but, you know, this is really just kind of some ponding. I mean, it's not even really coming into the tires there of the vehicle. So just be careful what you report as flooding. Now this is good to report. If you can estimate, say, hey, water is halfway up, you know, the tires. That's useful information. Or this, you know, this is flooding that needs to be reported. But also add context. So this is a street that always floods. Let us know too. Say, hey, we have water halfway up the tires. This is a street that always floods, though. We may do a flood advisory instead of a flash flood warning in that situation. Because flood advisories tend to be for more nuisance flooding, you know, where it typically floods. While flash flood warnings tend to be more where flooding is occurring that typically doesn't happen. This, obviously, you want to report and hopefully not drive over, because you can't tell if the road is still there in this situation. It may be gone. And again, this is an example where you can report it, but you'll notice there's a little thing that says high water levels. This is probably a location that always floods. So yes, reported, but also add context. Say, hey, this is a low water crossing that always floods when it rains. Because we'll know that, and we may do a flood advisory in that situation, whether instead of a flash flood warning. So when you give a report, you know, you want to say your name, I'm a trained spotter, and again, your location, again, location that's easy to find, and then what is occurring and when. So you can call our office, that's the number, 405-325-3816. It's also on the bottom of our website as well. So that's the number you can call to give a report. There's also a spotter network, and I saw some people taking pictures, so I'll leave this for just a second. So again, that's the number, 405-325-3816. I think everyone's taking their picture. I see someone still taking a picture. All right. And then spotter network is another way you can give reports. So this one, I think you do have to take a little test, but Nice thing about Spotter Network, I think there's apps for the phone, and it actually includes the latitude and longitude, so we know exactly where you are, which is nice. Amateur weather radio. Now, that may not be monitored continuously, but what we do have is we have people that are relay information to us through the local net control via radio or NWS chat. So we have people that may relay the amateur radio reports to us. And then MPing, it's an app you can download on your phone. It's really great for reporting hail signs especially. So, you know, it basically includes your latitude and longitude information, and you basically can report hail. You can also report winter precipitation type, like if you're getting snow, sleet. We use that quite a bit as well, but hail is a really nice feature of that as well. Social media, you know, may not be the best way. X is better than Facebook. You guys who use Facebook know the timelines can be kind of wonky, right? Where you may see something that's like, you know, 3 weeks ago sometimes on Facebook. So Facebook is a good way to report things after the fact, but it's not the best to report real time, because the way Facebook works, we may not see it in real time, but if you have something to report, especially, you know, the next day damage, it's still a great way. X is better. Include what, where, when, and again, pick a video if you can do so safely. Email, you know, it's not for urgent reports. So, but if you have reports, pictures, damage after the fact, you can send that to us. Also, make sure to let your local, you know, emergency manager know as well, because they may want to know the damage. They may not know if the damage is in your area. You want to make sure your local officials know about the damage too. But again, reminder, your safety is more important than any report, picture, or video. So again, never ever risk your life to take a video or picture, because it's not worth it. All right, with that, I will take some time for some questions here. Does anybody have any questions? Any questions? I guess that's a good sign. Well, I appreciate everyone's attention. Oh, yes.
So you unless you're going to be meteorologist, what would be your best resources?
So what year is he in?
8th grade.
8th grade. So yeah, if you wanted to meteorology, one thing people don't realize, meteorology is a lot of math and physics. So it's basically applied physics. So the big thing I recommend, especially middle school and high school students, especially early, is try to take as much math and physics as you can, because math builds. So you start with arithmetic, right, in elementary school. Then you go into algebra, and then you go into, you know, geometry, pre-calculus, calculus. So it's like reading, it kind of builds. So I would always tell students who want to do meteorology, try to take as much math and physics as you can in science classes when you're in high school, because that's what most actually find challenging, is the mathematics, because it's basically applied physics essentially. So I had to take, you know, for meteorology, you have to take 3 calculus courses, and then you got to take the statistics class, and you got to take ordinary differential equations, which is after calculus. So, and you know, that's probably my strongest suggestion, is try to hone in on those math skills, because if you can hone those math skills in high school, it'll make college easier. Does that kind of help? There? You have any more questions? You can see me afterwards too. So. Any other questions?
What about microbursts?
I had one. I know the government has done a lot of cutbacks with this as far as funding with the weather station down there in Norman. Is that all been circled around? I mean, obviously.
Yeah, the Weather Service is actually hiring now, so we have funding and everything is good. We're all in good shape. So they're going to be starting to hire more and more people. We've hired a couple people late last year into early next year, so that has been taken care of.
Okay, good.
Yes.
What about microbursts?
Yeah, microbursts are basically actually the downdraft. When the storm is collapsing, that produce. If the downdraft is very narrow, usually that's what a microburst. And you can have like 60 to 70 mile-an-hour winds from microbursts. It's basically a lot of times we see that in the summertime when a storm is collapsing. It's really really hot in the summertime, so the evaporative cooling, because it's so hot, results in a strong downdraft, which can produce 80 plus mile-an-hour winds.
Yeah, there was a building in Public City that got completely destroyed by a microburst.
Yeah, microbursts can be similar to straight line winds, and they are considered straight line winds, but similar to squall lines, they can produce winds as equivalent to a weak tornado. So, and they are actually very dangerous to aviation as well. Back in the 1980s, there were a lot of aviation incidents that were due to microbursts. There was like the 1985 Dallas plane incident that was due to a microburst. Other questions? All right. Well, appreciate everyone's attention. And stay safe this season. And
Thank you.